important for you guys to know that rate of change.
It's not important.
Rate of change is the same thing as slope. So you'll see these terms used, but they mean this exactly the same thing. It'll say in one problem, find the slope of this. And then in the next one, it will say the same thing, except for it'll say find the rate of change. It's the same thing. Again, we do this in math because the more terms we use for the same thing, the more intelligent we appear to be. Okay. Now, the rate of change and the slope for a proportional problem, they call it something different, and we heard about those yesterday, the constant of proportionality or the constant of variation. They are the same thing. So, in other words, sometimes we'll have a proportion, it'll say find the rate of change, though. But it's the same thing, right? Yeah. The nice thing about the rate of change is it was discovered back in the 1400s by the Irish family, the O'Changes. That's where it comes from. So when we look at an equation, let's just start with the equations first, okay? Hold on. With equations, this is the way you're going to see most equations. Is y equals, give me a number.
2.
2.
Yes.
2x plus 7, sure.
Yeah.
Okay, when you see this, first thing you need to do, because we got to differentiate between the two, is this equation proportional?
No.
Would this equation give us a proportional relationship between x's and y's?
No.
Why not?
Y is by itself.
No, that is not y. Well, it is y, but it's not y. So, very good, Caitlin. It's plus 7, okay? Whenever you have plus or minus stuff in an equation like this, it's no longer proportional, okay? Now, this is linear, though. It is still linear, it's just not proportional. Alright? Let's look at another example. So, y equals, give me a number.
7.
7, what else?
9.
We already used 2, let's use 9. Let's make it negative, that's an x.
16.
Give me another one, sure, minus 16. Okay.
7,000.
Alright, if this is the equation, is this proportional? No, it is not. Now, again, we are talking about rate of change, though. So let's do rate of change. These two equations do have a rate of change. First thing we need to do is look for the coefficient of x. What is the coefficient of x? And the first one, let's start with the top one.
2.
2. That's our rate of change. This next one, what is the slope of this next equation?
Negative 7.
Negative 7/9. Excellent work.
On a graph, you just go over 7.
No, and I'll explain that in a second. But the next thing we need to do is look at a table. The last thing we will do is consider the graph and how to find the slopage from graph. All right. So, all right. So let's go to this one. So this is another example. We did equations. Now let us do a table. Okay. With a table, first thing we need to do is make a table. So here's a table right here. Okay, we're going to use, we need 3 values, so let's get another one right here. All right, and we are going to compare, okay. Let's look at this. So let's say when you buy 2 pizzas, bam, it's going to cost you 18 smackaroos, okay?
That's a lot of money.
When you buy 3 pizzas, 26.
That's not proportional.
When it buys you 5 pizzas, it's going to cost you 42 schmackers. I guess I don't need this bottom one. So. All right, well, let's find the rate of change. Let's consider first, though, if this table gives us a proportional relationship, okay? Is this a proportional relationship?
No.
No. 18 divided by 2 is 9. 26 divided by 3, not 9. That's all we need to really look at, okay? So this is not proportional, so we need to find the rate of change, okay? So when finding the rate of change, actually, let me come back here. All right, it's important for you guys to realize the rate of change is just the change in y divided by the change in x. All right? So it's always a fraction. Okay, so we'll make another fraction here and figure this out.
2.
Well, notice the y's, the changes in y's is the numerator, and the y in this table represents
18.
dollars. So we need labels. All right? The changes in x, what does x represent?
Pizza.
Pizzas, okay. So we're going to have pizzas. All right, with this one, we're going to say that this one is linear, so we don't have to worry about that or not. So all we need to do is choose two of the values. So you got 2 and 18, 326, and 542. Which two do you guys want to use?
2 and 18.
All right, so 2 and 18 and 5 and 42.
And 3 and 26.
Well, we're going to use those two. Okay. We only need 2. Well, let's find the change in y first. So with these tables, the y values are always on
Left.
the right.
Right.
The x values are always on the left. Okay. When they have horizontal tables, I'll show you how to figure out if it's x or y. All right, but not right now. Let's finish this problem. So the change in y. So we're use these 2 points. So from 18 to 42, we're going to go from 18 to 42. So we're going to have to increase 18 by how much?
42.
Well, you got 42. Some of you say 42 minus 18. Or 18 plus what is 42 is 24. Good. So in other words, the increase in dollars was 24. Now remember, we did that because our numerator is the change in y. But we now need to figure out the changes in x. So let's do those. So from 2 to 5. From 2 to 5, it will increase by 3. So I've got an increase of 3 pizzas. $24 change for 3 pizzas. This is going to give us a simplified fraction of, very good,
Wait, so you pay
$8 for 1 pizza.
But that's confusing because
All right, so Sydney brings up a good point. She says for $2, for 2 pizzas, it's 18 bucks. So if you buy 2 pizzas, it's going to cost you 16. What are the other $2?
change.
Probably some kind of delivery fee, something like that. Okay. Now this is something that you have to label because the x's and y's were labeled. So make sure you label these. Okay. Now, in case you guys forget about this, there is a poster over here right underneath the speaker. So these are the many different ways we look at slope and rate of change. Rate of change and slope are also represented by one letter, M. It's Greek for slope.
I'm gonna
I don't know Greek, so I don't know what it is.
and the rest of
It told you right there, it's change in y divided by change in x. Some people say it's the vertical change, okay? Because y goes up and down, so that's vertical. Horizontals, right and left. So that's change in x. Some people call this rise over run. And there's a little equation there that you'll learn about more in 8th grade. Okay? So in the book, whenever you see a table like this, they'll give you the quantities, but it's always the x is on the left, y is on the right.
Can't switch it up.
Okay, so when you find your changes on these, you'll do the change in y divided by the change in x. Now, one of the biggest problems most people have is because the book does this because they're jerks, is the y values now are on bottom, the x values are on top. So when you find your change, you've got to find the change in y first, and in your fraction, this is the change in y, okay? It's always the numerator. Then you'll find your change in x. Okay? So please don't let that confuse you. All right, now if some of you look at a table, here's something you always need to know, is that x values if this exists, okay, time Time are always x values. Now, this doesn't matter. That means time is always your x values, because you have x values and y values. X values, y values.
What if the B
Now, this doesn't matter what type of time it is. Maybe it's in seconds. Sometimes it's in minutes. Maybe they'll throw you a curveball and put it in hours. Okay? I don't know.
What if they
Change up
What if they
and
put it in nanoseconds?
Maybe they'll change it up and they'll say it's in a day. Okay?
What if they do nanoseconds?
What if they go as high as, I don't know, a week?
A year.
Okay?
Millennium.
What about a month? Maybe they'll do a month. Sometimes they'll do a year.
What about a nanosecond?
Or maybe a decade. I don't know.
century.
Or a century.
And millennium.
What about a nanosecond?
Maybe they'll do a millennia. Maybe they'll do a light year. All of these are forms of time, and they are the x values. Let's consider. All right. What's another name for rate of change?
Constant rate of change.
Yeah, sloppage.
Slopage.
Some people thought this was inappropriate, so they called it slope. This is a horizontal table, so are the x values on top or bottom? X values on this one are the top values of the table. In the ratio, they are the denominator, though, okay? So the cost is the y's. So all right, so our rate of change is a fraction. And let's find our change in y first. So from 1,000 to 2,000, it changed by increasing 1,000. So my change in y is 1,000. The change in y is on top. It's the numerator. The change in x is going to increase by 50, right? 50 plus 50 is 100. So this is 50, but we do need the labels. The y's were represented by dollars right there. Okay? The x's were represented by lines of code. I'm just going to write lines because I'm too lazy. Okay? Well, this can be simplified, but this labels stay the same. So dollars and lines. 1,000 divided by 50 is, very good, it's $20 for one line. Done. That is our rate of change, or the sloppage. So the rate of change or the slope, again, it's going to be a fraction. And before I start this, I can label my y's are represented by
Minutes.
dollars. Okay, because in a horizontal table, the y values are always on bottom.
Oh yeah.
X values are on top. So my x's are represented by minutes.
Minutes.
Well, let's find our changes in y. So which two do you guys want to use? 1,038, 1,553.
2,000.
All right, we can use this one, and what else?
1,000.
Sure. All right, so from 38 to 68, it increased by 30.
Oh yeah.
So $30, and an increase in minutes was 1,000. Now, sometimes you'll have a decrease. If it does decrease, it's just negative, right? So it increased by 1,000 minutes. Can we simplify this?
Yes.
Oh, yeah. So let's label them as well. So we got minutes, dollars. What does this simplify to? 3/100ths. So it's $3 for 100 minutes. I can't simplify it any further because my rate will change.
Rate of change.
Or some sloppage. So graphs are just a little bit different. There's a couple ways you can do it. All right. The first way that I'm going to show you is You have to use these steps right here like this, okay? So remember, we're going to write this as a fraction. Now the first thing I need to do is the change in y. Is y up and down or left and right? It's up and down, so I need to choose 2 points. Which 2 points do we want to choose?
12 and 144.
12 and 144, and what else?
672.
Sure, that's fine.
Oh, I hate slow.
Now, in this, I have no idea. It's just an example. All right, what you got to do is you're always going from the point to the farthest left to the point to the right. Well, this point is farthest to the left, and I'm going to go to the right. So I'm going to start at this point right here. Does everyone see that? I'm starting at this point, 672. Okay, good. Okay, well, since we are going to the right, okay, but first we need to find our change in y. Well, change in y is up and down, so I've got to go up. And in my y values, I started at 72. I'm going up to 144, so how far up did I go?
144 minus 72.
And 144 minus 72 is
75.
72.
Oh.
So I increased this by 72. Let's label this. What are my y values represented by?
Why?
Pages printed. I'm just going to put pages. That's fine. What's my change in x? Well, I went from 6 to 12. So it increased by 6.
So you pretty much just have to.
And very good. It's in minutes.
You pretty much just have to do 144 minus
This can be simplified.
72 divided by 6.
And it would be very good. 12 pages
4.
for 1 minute. Bam, rate of change. We found it. All right, here's another way to do it. Using it with a graph, okay?
Could you just do
Just make a table.
12?
Because some of you are like, I can do tables all day. Okay, well, you got your x and your y values. You got 0, 0, you got 672, you got 12 and 144, and you've got 18 and 216. Well, from here, you're just going to use the same method to solve for your rate of change. So, yep, maybe 12 over 1. Okay. But once again, you get to choose in the table which values you want to use. So we went from we just turned the graph into a table, found the rate of change, simplified. Done. All right, here's another example. So they're just washing cars for some kind of money. Does money or number of cars represent the X values? Which of these is the X values?
Numbers!
Numbers. Why?
Because it's on the right.
It's on the left. Very good. So money will be our Y's. Okay. Well, you'll notice the change for all of these is 40 to 5. So your rate of change is $40 per 5 cars rather. And this would simplify to $8 per car.
Hallelujah.
Hey, no, he already said.
Well, this is an example in the book, and they showed you guys how to do it. All right, so A, we're going to do, okay, so it is a fraction. Well, we needed a change in Y, so for a horizontal table, it's the bottom one. So from 290 to 580 is an increase of 290. Oh, that's rough. Okay, so you got an increase of 290 what? Miles. And the increase in X, up by 30, very good. And it's 30 minutes, very good. This would simplify into, well, you're still going to have miles and minutes. What does this simplify to?
23.
20, oh man. 29 thirds, right? So 29 thirds. Well, this is just 29 miles in 3 minutes. Hey, that's pretty fast. All right. Which of these is the Y values, buses or students? Students. What is the X value then? Buses. Done.
He said I could go.
Okay, so let's find the change in Y. So 144 to 216 is an increase. So this is going to increase by 72. Very good. So 72 students. And from 2 to 3 is an increase of 1. So 72 students per bus. There's no need to simplify. This is our rate of change. Yeah, don't worry about what the book put in this. We already solved it. And we already talked about how to find the rate of change on
I have a question.
using 2 different methods. There you go.
Whatever.
All right, when looking at, it's going to say, explain what these represent. Well, that's not really as hard as you think, okay? Because notice you've always got your X and Y values as points. And in this one, it told us the X values were in hours, and the Y values were in miles, okay? So when it gives us the point 0, 0, it's just 0 hours for 0 miles. So you would say this is 0 miles per 0 hours. Or that's how far they went. So 0 miles in 0 hours. Either way.
Two numbers.
No, it told us to use 0, 0.
I know, but
Let's do 160 now. So 1 hour, 60 miles. So that'd be 60 miles in 1 hour. Done. All right, here is C and D. All right, let's look at this one because they will ask a question on this, okay? So this one has a table and a graph. You got to find the rate of change, and in this case, we want to know who saves more each week. Let's look at this one. Let's look at Mealing's rate. So it's going to be dollars for weeks. So how much dollars per week is Mealing saving? How much dollars per week is Mealing saving? $15 for 1 week, okay? So you can see this is a change in 15. This is a change in 1. All right, what about Daniel? How much is he saving? $10. Very good. $10 for 1 week. So who saves more each week? Mealing does. Because Mealing is saving $15 every week. The explanation, this should work. Okay. Micah?